First question from Chinese. Hi, Kevin. Thank you so much for the PANDAS tutorial. I've really improved my skills in PANDAS after going through the tutorials. There's one topic that I could not get a good hang of. It is merge and join based on columns and indexes. I know this is a big topic. Can you explain it? All right. So let me go ahead and share my screen. And here's my plan. I'm going to cover kind of 4 sections in this lesson. And the first section is about selecting a function, meaning which function should you use to merge and when. The second is the bulk of the lesson. I'm going to go through a relatively simple merge, but really talk through it in detail so you feel like you can get it. The third section is called What If, and it's about common variations to the basic merge. And the fourth is about the 4 types of joins very briefly, because you'll also need to use that depending upon the scenario. So that's my plan. Let's just jump right in. And again, if you have a follow-up question, feel free to post it in the chat. So part 1, selecting a function. Here are the functions related to merging that you might want to use at some point. So there's 2 at the top. One is a DataFrame method called append, and it takes the format, DataFrame1 dot append DataFrame2, and that's for stacking things, but only vertically. Then there's what's called a top-level function, pd.concat, and you pass it a list of objects that you want to concatenate, and that will work either horizontally or vertically, okay? So those are kind of similar. And then you've got 2 more functions. You've got df1.join df2. So that's certain types of joins, and that's a DataFrame method. And then you've got pd.merge, another top-level function for merging. Now, here's my recommendation. I never use append. I only use concat. I never use join. I only use merge. Now, why is that? Well, append and concat have very similar functionality, except concat is more flexible. And similarly, join and merge have similar functionality, but merge is more flexible. So my philosophy is, why bother learning all 4 if you can just learn 2 of them and handle learning these concat and merge? You can handle all scenarios you might ever see. Okay. So there's no point in my mind in using append and join, just use concat and merge. Okay. And they are both top level functions, meaning you say pd dot something and then you pass all the objects. Okay. Now I'm not going to cover concat because I do talk about concat in my PANDAS video series. So check that out and I can share a link to the particular video. But I don't talk about merge in any of those videos, which is why I'm going to go in depth on it here. So we're going to focus on this last one called merge. Okay. So part 2 is about the actual merging of data frames. And when I say merge or I say join, I really mean the same thing. So I've got some data sets I'm going to pull up that I think will demonstrate this well. And you won't be able to follow along right now because you won't have the files. I will post them afterwards, but you're not going to have them right now. So I've got 2 data frames that we are eventually going to merge. And it's important to understand the structure so that when you see the result, you can understand what happened and why. The first is called movies. And don't worry about the file reading code. That's not the important part here. What we're looking at is a data frame of movies. It's got 2 columns, movie ID and title. The data frame has 1,682 rows and 2 columns. Okay. So this is if you're not super familiar with PANDAS, this is the index. This is the movie ID column, and this is the title column. So every movie ID relates to one title. kind of makes sense. There are 1,682 movies, and we're going to select the movie ID column and run the nUnique function, or method rather, series method, and it's going to be 1682, which is my way of showing to you that this is a unique identifier. All right, I know this setup is taking a little while, but bear with me. The payoff will be worth it. So the other data frame is called the ratings data frame. It has 4 columns: the user ID, movie ID, rating, and timestamp. In other words, this user gave a rating of 3 to this movie at this time, and that's a Unix time, so that's why you can't read it really. Okay, so this user gave this rating to this movie at this time. Okay, there are 100,000 rows, so that means there's 100,000 ratings, and we're going to look at the nUnique of the movie ID column. There are exactly 1,682 movie IDs in here, just like there are 1,682 movie IDs here, and they're the same movie ID. Now, the last thing I want to show you before we do the merge is, let's run this right here. And what I'm saying, I'm using the .loc accessor, and I'm saying, what rows do I want? I want the rows in which ratings.movie ID is 1, and I want all columns, and then I want the head of that. Okay. So what am I just showing you is I want you to see what some ratings of movie ID 1 look like. And you'll notice these are the index values. So the 25th row in the ratings data frame is a rating of 4 by this user ID of movie 1. So I just wanted to show you this, and this understanding what you're looking at here will come in handy a little later on when we're understanding the results of the merge. Okay, so now I've set up what is the movies data frame and what is the ratings data frame. Now, if we're merging it, what would be the point of merging it is the first question you'd want to answer. And one reason would be, let's say you want to study the ratings data, but you want to see what the movie name is, because 242, like, you don't care who this person is, and you probably don't have any information on them. But the movies, we want to know, what is movie 242? And we have that data. It's just not in this data frame. So that's why we want to do the join or the merge. Again, same thing. So that's our motivation for the merge. Now let's go ahead and do the merge. But I want to show you just a recap of what columns there are. And this is key. Movies, there are 2 columns in movies. There are 4 columns in ratings. What I'm going to do is I'm going to use pd.merge, and I'm going to pass it movies and ratings, because you can see that the format of the merge function is what's the left data frame and what's the right data frame when you're merging. Okay, so I'm going to merge these 2. I'm going to save the result in movie_ratings, and then we're going to look at the columns before I show you the result. Now, when you do a merge, it will merge on all columns with the same name. In other words, it will match on movie ID because they have the same name by default. Okay, so notice the resulting columns in movie ratings, which is the data frame that is the merge of these 2. We see 5 columns: movie ID, title, user ID, rating, timestamp. Notice the order. You get both of the columns from the first data frame in order: movie ID, then title. Then you get user ID, rating, and timestamp in that order. It skips movie ID because that's what you joined on, so it's not going to list it twice in the result. Okay? Now that I've showed you which columns, let's take a look at the head and actually see the result. Okay. So again, movie ID, title, user ID, rating, timestamp. All right. So what happened? First thing that Pandas did in the merge is it said, okay, the first movie ID in the movies data frame is 1, and the title is Toy Story. So let's put that right here. Then it's going to look for movie ID in the ratings data frame. And every time it finds a match, it's going to create a new row showing the user ID, rating, and timestamp from that row. Now, this may look familiar because you've seen it already up here. User ID 308, 287, 148, 280, 66 did these ratings. And here they are again. Okay. So essentially, it's trying to find every instance of movie ID 1 in the ratings data frame, and it's building a row with the other columns from ratings that match to it. Okay. Now there are 100,000 rows because that's how many ratings there were in the movies data frame. It doesn't just try to find one match. It tries to find every match in the right data frame to the things in the left data frame. Okay. So that is what has happened in the merge so far. Okay. And this is just a narrative about all of that you are welcome to read later. Just a quick recap of the shapes. So movies was 1,682 rows and 2 columns. Ratings was 100,000 by 4, and movie ratings is 100,000 by 5. So you added the 2 columns plus 4 columns minus the 1 matching column, and you get 5. And there's 100,000 rows because there was a match in all 100,000 cases. Okay. So that's what happened in this basic merge. All right. This is my what if cases. First question. What if the columns you want to join on don't have the same name? Okay. So let's create that scenario. We can overwrite the columns attribute of movies, and let's just, instead of movie ID, let's make it M_ID. Okay. So those are the movie columns, and here are the rating columns. If we try to do a merge, it's going to fail because there's no matching column names. Okay. So if you want to merge this, remember the data hasn't changed. If you want to do the merge, you use these 2 arguments, left on and right on. In other words, I want to join on this column in the left data frame and join on this column in the right data frame. And if we do that, we'll get the same exact result as before. Okay. So that was the first what if the column names don't match. The second what if you want to join on an index? And I'll get to joining on 2 indexes, but let's start with joining on 1 index. And this is a little confusing, but let's go ahead and set the index as MID. Okay. And you'll see now the MID has moved to the index. Okay. If you want to do the join, in this case, you say left index equals true, right on movie ID. Okay. So previously we said left on. This time we're saying left index equals true. Now, why isn't it just like left on equals index? That would have been another option for how they could have created it. But, you know, you might have a column named index and whatever. The point is, if the thing you're trying to join on in one of the data frames is an index, you just say left index equals true. And then in the right data frame, you're matching on movie ID. Okay. Now, there's a funny thing that happens. This looks exactly the same as before, except the index has changed. So this is a little tricky to understand why this would happen, but if you really think through it, it kind of makes sense. The index from the right data frame got used as the index of the result. Okay. Now, why would that be? Well, we joined on the left index with a column called movie ID. So you don't really need to keep this index in the result because it already matches movie ID. So there's no point in using this as the new index. There's just no point. However, you might as well, rather than using the default index of an integer starting at 0, you might as well use the index from the right data frame. So even though you might think that's like the reverse of what should happen, it uses the index in the result from the data frame that you did not match on the index. Okay. It's a bit of a complicated logic, but hopefully that was helpful. And then let me get to joining on 2 indexes. Then I will get back to your question, Todd. So what if you want to join on 2 indexes? So let's do that. And now we've set the ratings data frame to have movie ID as the index. Okay. Now both of our data frames have an index and we want to join on it. In that case, we just say left index equals true and right index equals true. And we'll go ahead and run that. And in this case, it uses the index that gets created is the index from the left data frame. Okay. So this is the index. It came from the left data frame. You might not know that you don't have to use a unique index in pandas. So there's, which is why the index is 1, 1, 1, 1, 1, 1. I mean, the index varies throughout the data frame, of course, but it does not have to be unique. Okay. So part 4 is the 4 types of joins. What we've been doing is known as an inner join, I-N-N-E-R, an inner join. But there are also other types of joins supported by the pandas merge function. They're the outer join, the left join, and the right join. Okay. And the easiest way to understand them is by looking at some examples. So I've got these 2 examples, A and B. All right. And then we're going to do those 4 types of joins, and you'll see exactly like the logic of those types of joins. Okay. And it'll make sense why you need to know which type of join to use. Okay. So, we've got A, which has 2 colors, color and num, and B, which has 2 columns, color and size. Now you're going to ignore the index. That doesn't matter. And when we merge these, they are going to merge based on the color column. Okay. Cause that's the matching, column name. Okay. So notice we have green, yellow, red, green, yellow, pink, 1, 2, 3, SML, like small, medium, large. Okay. So inner join, and the names will make sense once you know what they do. The inner join says only include a row in the result if the thing you joined on is present in both data frames. Okay. So here is the result. Now notice there's this how argument, and by default it's inner. So you'd get the same result if you just didn't have this. But I just want to be explicit. So how equals inner. Okay. Now, because red was not found in B and pink was not found in A, neither of those show up in the result. Okay. And so green, yellow, 1 and 2 from A, and then green, yellow, S and M from B. Okay. So that's our result with an inner join. Outer join is the kind of the opposite. It gets included regardless. All the keys get included. So we get green, yellow, red, and pink. So we get green, yellow, red from A, and 1, 2, 3 from A, green, yellow, red, 1, 2, 3. But what happens with pink? Because pink has no num, so it gets filled with NaN, which is a missing value. As well, you get green, yellow, pink from B with sizes small, medium, and large. But because red is not in B, its size gets marked as missing. Okay? So inner join includes only the matching. Outer join includes all. Okay? And missing values just get marked as missing. Left join, you keep all the keys from the left data frame, regardless of whether they match. So in the left join, since pink was not found in A, you don't include that row, and you do have an NaN value for size. NaN value for size, okay, by red. Right join, you have green, yellow, pink. It says, okay, we're going to include everything that's in B. So we include green, yellow, and pink. We include size small, medium, large, but pink doesn't have a num in A, so it gets marked as missing. Okay? So those are the 4 types of joins. You know now most of what you need to know about merges and joins. And there's some more functionality available within pd.merge that you can read about as needed. Hope this video was helpful to you. If you'd like to join my monthly webcasts and ask your own question, sign up for my membership program at the $5 level by going to patreon.com/dataschool. There's a link in the description below, or you can click the box on your screen. Thank you so much for watching, and I'll see you again soon.